Good morning. My name is Akanksha Malhotra and I am in the F2 slot of Business Analytics. Today I will be talking about data visualization based on databases related to automata theory. Okay, let's imagine that computers are like robots that can do certain jobs. Just like how different robots can do different jobs, there are different kinds of computers that can do different things. Automata theory is like a set of rules that tell us how these computers should work and what kind of jobs they can do. For example, let's say you want a computer to play a game with you. The computer needs to follow a certain set of rules in order to play the game, like when is it their turn and when they can make a move. Automata theory helps us understand what rules a computer should follow and how it should make decisions. It's kind of like a game of chess where each piece has to move in a specific way. And the game has rules about how the pieces can move and capture each other. In the same way, automata theory helps us figure out the rules for the computer so it can play the game correctly. So, in short, automata theory is like a set of rules for computers which help us understand how they should work and what kind of jobs they can do. Automata theory is a branch of theoretical computer science that studies abstract machines and the computational problems that can be solved using these machines. Simply put, it is a way of modeling and understanding how computer algorithms and languages work. In automata theory, automata refers to abstract machines that perform specific tasks such as recognizing patterns in data or processing strings of symbols according to a set of rules. These machines are defined by a set of states and transitions and can be thought of as the simple, idealized models of real world computing systems. The study of automata is important for several reasons. Firstly, it provides a mathematical framework for understanding the limits of what computers can do and what types of problems they can solve. Secondly, it forms the basis for studying formal languages, which are used to describe and define syntaxes and structures of programming languages. Thirdly, automata theory has applications in areas such as artificial intelligence, cryptography, and computer security. In summary, automata theory is a fundamental part of computer science that deals with the study of abstract machines and the computational problems they can solve. One important use of automata theory is the creation of programming languages. These are like special languages that tell computers what to do. Automata theory helps us make sure these languages are clear and easy for computers to understand. Another use of automata theory is in the field of security. It helps to make sure that the information you share online is kept safe so that no one else can see it. And finally, automata theory is also used in development of artificial intelligence and machine learning. This means that computers can learn from experience just like people can. Automata theory is important in computer science for several reasons as it helps in understanding the limits of computation. Automata theory provides a mechanical framework for understanding the limits of what computers can do and what types of problems they can solve. This helps computer scientists and engineers make informed decisions about what problems are suitable for computers to solve and which ones are not. Formal languages. Automata theory forms the basis for the study of formal languages, which are used to describe and define the syntax and structure of programming. Languages. Understanding formal languages is important for writing context and efficient code and for discussing new programming languages. Algorithm design. Automata theory provides techniques for designing algorithms that can solve specific problems. For example, automata can be used to recognize patterns in data, such as recognizing words in natural language text. Security. Automata theory has application in the field of computer security, such as in design of secure communication protocols and analysis of security vulnerabilities. Artificial intelligence. Automata theory is used in development of artificial intelligence and machine learning algorithms, as these technologies often rely on recognizing patterns and data and making decisions based on these patterns. So now I will be using R to uh, I will be using R to uh, open BiblioShiny and Yeah, I will be using R to open BiblioShiny, and then I will be visualizing databases that I download. So the first thing we need to do is we need to go to RStudio, and then what we do is we need to install bibliometrics. So for that, I can hop and show you. The first thing that you need to do is you need to install bibliometrics. 1 minute. And then you install the source package. And then you can run the same code again just to see if if it was installed properly or not. If it was installed correctly, then it will update if there were any new version, otherwise it will show an error. So it was installed perfectly fine for me. And then you go to library bibliometrics, and then it will open the package for you. Because and then you just need to write BiblioShiny with parentheses. So I can install BiblioShiny again just to show you how we need to do it. So yeah, and then this will open BiblioShiny for us. 1 minute. So you can see that it opened BiblioShiny for us. What I will do is I already have it open on different browsers. So I will be using the BiblioShiny I have on this browser instead, because all you can, yeah, so this is BiblioShiny. But what we will do is before we do that, we need to download databases from Scopus. So we go to eGateway, and then I'm already logged in. As you can see, I'm already logged in. And you go to databases, right? And we will be using Scopus databases to analyze. So we go down and we scroll down and we would come to bibliographic databases. And now we select Scopus. And here now we have all databases. So what we will do is we can search documents. So what I'm going to do is I'm going to search for automata theory in double quotation marks. And this will show us all documents that are related to it. So we have 30,326 document results related to that, but we do not want to no, that is a lot of data. I mean, you can use 30,326, but I would personally be lowering this by refining my results. Now what we can do is we can refine our results based on whether they are open access databases or not, what years they were published in, what the authors are, what the area is it related to, what is the document type, is it a review paper, is it a conference review, is it an article, is it a book chapter, and then you can divide it based on the titles or what keywords do you want, or what is the article or the document affiliated with, or if they have any funding sponsors or not, or if you want to restrain to a certain region, like United States has 6,203 articles, and France is 3,303 articles, and China has 2,345 articles. So if you want to make your study region limited, or a country limited, or a territory limited, or a continent limited, we can do that too. So what I will be doing is I will be taking articles which have been published from 20 to 20. So I will be taking, no, there have been 36 articles published in 2023 itself, and it has only been 1.5 months, which is amazing. Now, just so that I have a little longer list, I will be taking from 2020 to 2023. And I don't have a problem with any access things, and I'm not going to go for specific authors, but I will restrain my database is to be based on computer science because I'm talking about its relevance in computer science. So, computer science, and I will also be adding our research papers from mathematics and engineering because they're related to my topic as well. And I don't have any relevance or like preference for document types or publication stages. But I think I'll take the final stage ones. I don't have any preference for the source title or what country or territory depend belongs to, and then I will just limit my papers. So it's going to reduce from 30,000 to 1776. See, now this is improvement. Now I'm only going to be my research paper. I'm only going to have 1776 documents. So what I will do now is I will select all of these and I will have a C. I will then export these into a CSV file. So CSV file exported to your downloads file for more details. Now you can see there is an Excel file named as Scopus bracket 2. It's because I already have downloaded two Scopus databases. So there's a second one here. But yeah, so you can download your Scopus files like that. Now what I will be doing is now we will wait for a minute so that this is downloaded. And then we will move on to Picture Shiny where we will do the final one. Now you can see here that we have limited subject area to computer science and math and the publishers from 2021, 2023. It only final stage research papers have been mentioned and so many engineering or math and computer science. So we have really limited our documentation from 30,000 to 1,776 and a document has been downloaded. So now we will move on to BiblioShiny. Now this is what the preface looks like. BiblioShiny and Bibliometrics are open source and they help in comprehensive science and mapping analysis. It is an R-based tool which helps in data visualization. So now what we will do is we will load data. Now to load data, what we will do is we need to import our raw files. Now the database we have chosen is Scopus, and now we will upload our Scopus database. Conversion is in progress. So now we are importing our raw data files that we just downloaded from Scopus database, and we will be studying and visualizing the same. Now we wait. Now this is the completeness of bibliographic metadata. Now what this is, it shows how many percentage of what metadata is missing. Like out of 1776, they have number of cited references and cited categories are completely missing, but it is an overall really good data type because you have a lot of information which has like less missing data, so the data is complete. You can save this metadata list, but I personally would not do right now. So you can just go there. Now this is our database. Like you can copy paste it if you want. Now this is all our data entries, like the paper and what is it about, and the website and what is it. Yeah, so basically you have all your database clusters here, and you can see all your data in it. Now we will be visualizing. Right now I will be talking about three basic visualization techniques here. Now I will be talking about word cloud, and I would be talking about tree maps, and I would be talking about thematic maps. Now word cloud is a it is a visual representation. All three of them are easy to understand visual representation methods, and I chose them because they are easier to understand even for a layman. And yes, so now word cloud is a visual I'm sure you have seen them in when you're searching for science project stuff. So what this does is now this is a visual representation of all important topics and how many times they have been used. So their impact and their importance defines the font of the word. Like automata theory has been used 1614 times, so it is really massive. And robots has been used 692 times, so it's comparatively smaller. However, if we come here, state of the art has been used 35 times, so it is very, very small. And then you have model checking, which was used 180 times, so it is comparatively smaller than robots, which was used on 692 times. And computer circuits was used 159 times. That is why it is comparatively smaller than model checking, which was used 180 times. And formal languages was used 44 times, and pattern matching was used 34 times, and model checking was used 42 times. Equivalence classes were used 43 times. So you get an idea about how important what topic is with respect to the databases we downloaded. So if you're like a layman, if you want to tell a layman what the database is about and you show someone this, so they will get a rough idea like, oh, so this. And this is visually appealing to humanize too. So, and it is easier to understand. So this has been used a lot. Now, the second way I would be talking about is tree maps, which are a lot similar to word clouds, except they show the importance and the percentage of its usage and frequency. Like automata theory had 1614 mentioned, and which makes up for 30%, and computer circuits had 159 mentioned, which makes 3% of the entire scope as thingy. And robots had 692 mentioned, so that makes 13%. So this is comparatively better than word cloud, but it depends on who your audience is. Like if you're going to talk to a little child who is still in school, or if you want to talk to a complete layman who does not want to go in depth about it and just wants like an overall idea. So you can just show them a word cloud and they will get an idea. Okay, so this. Now, if a person wants to go a little deeper than a word cloud, then they would probably see a tree map, because now you see, okay, so 30% of what you're talking about is automata theory, or 3% of what you're talking about is model checking, and or 2% is semantics. So you get a numeric idea about what the data is, and you can also see the words frequency over time. So this will give you an idea about at what time what words were used. So like this is the line for automata theory, right? Automata theory, it was used comparatively lesser in 2022, but as 2023 came, its usage kind of faded. You see, so automata theory, it was 631 and then it's 1590 in 2022. So automata theory went from 631 to 1159 to 1592 to 1614. So you can really see the increase in frequency of usage of the term automata theory over time from 2022 to 2023. Keep in mind that the data I used was only from 2020 to 2023, so that it would be easier for me to visualize the data. So if you go over a relatively longer time concept, then you can see a longer, like you can still understand that it was comparatively used lesser in 2020, like it was 631. So in 2019 it was probably lower than that. So you can really see the growth, like you can see the growth of the term over time. And on the other hand, for example, computer circuits, it was 73 and then it became 155. So computer circuits still do it doubled over time, and it doubled in 2 years. Timed automata in 2022 was 138 and timed automata was 140. So there was not a massive development in timed automata from 2022 to 2023. However, I'm sure there has been a gradual improvement with respect to 2021. 39 from 39 to 138. Now that is massive improvement with respect to 2020 to 2022. Now 2023 has just begun, so over time we can expect a higher in one of these topics. So you have themes like um model checking. If you really like, yeah, you can. I'm going to go in detail over here. So now these are comparatively lower occurrences, right? But you can see now robots, polynomial approximation is here, and model checking is here. So if you look at them like in detail, you can see that timed automata, semantics, robots, polynomial, computer circuits, learning, algorithms, learning automata. I already mentioned that automata is all about algorithms. So it helps us in visualizing the same, and you get an idea about how it grows. So this is a very helpful way in understanding the growth of certain themes and trends. Now we can see different trend topics too. It is similar to the previous one I showed. It talks about what topics and what themes have been trending and what, yeah, like in 2022 themes like polynomial approximation, artificial and robots were important, but over time in 2021 and 2021 it was automata theory and model checking and computer circuits. So you can understand that in 2020 things like robots and AI and polynomial approximation had the wheel, but over the time then it was automata theory, model checking and computer science. And now it is deterministic property and automaton. So you can see what topics were trending, what year, just like how I showed you before. You can also see what work has been cited and what authors did what. Now, the next thing that I want to show you is a thematic map. So what thematic maps are very helpful in studying data. So now you can see that this thematic map has been divided into 4 different regions, right? Sorry. Now you have niche themes, you have motor themes, you have emerging or declining themes, and you have basic themes. Now, if you see it, this is the x-axis, this is the y-axis. Now, this talks about centrality or the relevance degree. Now, this goes from lesser relevance to higher relevance. Okay, now this is lesser relevance to higher relevance. So on a topic, automata theory, talking about polynomial approximation, computational complexity, graph theory is comparatively less relevant with respect to topics which are more mainstream like automata theory, robots, and model checking, which come on the positive side. So if you're comparing, then learning automata, reinforcement learning, decision making comparatively less relevant than polynomial approach computational. So the x-axis basically gives you an idea about what is more relevant to our topic. Like my main theme is automata theory. So the most relevant stuff based on my theme is going to be on the positive x-axis, which means this side, like this, and this entire x-axis would be more relevant than this axis. these two regions are going to have comparatively less relevant stuff to the main with respect to the main theme. And now the y-axis, which goes up and down, now that talks about the development degree or the density or how much impact the topic has. Now it goes from negative to positive again, and like the least impactful stuff to the higher impactful stuff. So now the motor themes are the ones which have high impact and they are high relevance too. So motor themes have I'm going to zoom in later, but like okay, 1 minute. Let me zoom in. Now you have motor theme. Now you don't have a complete motor theme as this database. Usually if you have like a completely motor themized aspect, which would be somewhere over here, it means it has high relevance and it has high impact too. But over here this comparatively still has high relevance and high impact. So let's talk about this computability and decidability, forestry and deterministics. Now they are in between motor theme and basic theme. Now basic themes are stuff which have high relevance, they have okay impact because they are talked about a lot. Higher impact also means that the chances of it being cited, like if you do research papers on those topics, then the chances of them being cited in other people's work goes comparatively higher with respect to these like learning automata, reinforcement learning, decision making. So the motor themes are the stuff with the highest impact and highest relevance. Now, the basic themes have lesser impact, but they are still highly relevant. So they have less impact because a lot of work has been done in that work, in that field, like automata theory, robots, model checking. Now, it's not that they are not impactful; they are impactful. Mind that, but they have a lot of work on generated on them already. So if you're willing to write a research paper, then you should not write it up on that because it already has a lot of work. Like it is still impactful, it is just a lot of work has been done upon it. So yes. And then we have the emerging or declining themes. As the name suggests, if there are topics which are emerging, like they exist, but they're not known like at all, like they have very low relevance in present date. It might increase over time, but they have a very low impact in the present date and they're like not relevant enough right now. So like AI was probably not relevant enough 500 years from now because computers should not exist. So it would probably be somewhere very low in the emerging thing because it did not exist. And then you have niche themes which are known and which have papers and they are impactful, but they don't have a lot of work on them, like learning automata. Now, people have written there is a lot of work present upon automata theory, but not a lot of people have written stuff based on learning automata. Wait, let me see, 102. So we have 102 frequency of one learning automata, while the term automata theory in itself has 1630. So you can really see the difference in the ratio from 1614 to 102. And it will help you get an idea about what needs more work, what needs less work, what is more relevant, what is less relevant, what is highly impactful, what is lower. Like the chances of it being cited is less. So that helps in visualizing data. Now this is an R-based work environment and you can filter your data and you can import it and you can study the same and you can visualize. There are more methods in which you can do the same, like you can talk about what work has been cited and what are the authors and what authors have worked together, what authors have not worked together, what countries have the least amount of work given, what countries have the most amount of work given. Now there are a lot of different bases in which you can visualize data, but I only briefly explain 3 or 4 of them because I lack the time for that. But this is automata theory for you guys in computer science. And yes, that is automata theory for you guys. And Biblioshiny is used a lot online. It is used by data analysts and business analysts and research paper writers to understand and have an overview on data. And I would like to end the session by concluding automata theory to be relevant and important in the field of computer science, as it provides techniques and tools for solving problems in areas like algorithm design, compiler design, natural language processing, security, and artificial intelligence. Now we can conclude that automata theory has a lot of impact on computer science, and it is highly relevant. And you can also visualize and understand and read databases with the same using Webber Shiny. Now I would like to end my presentation here. My name is Akanksha Malhotra and my roll number is 21 BCE 3152.